So, this is the problem that we're going to be solving. Now, when solving equations like this, there's a lot of different stuff going on in it. You notice there's some addition and subtraction going on. In this case, just addition. There's some multiplication going on. And when we're solving equations, we're undoing it. So the question is, what order do we do it in? And for that, we can actually go back to our order of operations that you know and that we were dealing with recently. And as you take a look at this, this order of operations is used for simplifying or evaluating expressions. In other words, if you got a whole bunch of just numbers in there, what do we do first in order to calculate our answer? But it's still useful when solving equations, but it's a little bit different. When solving equations, we are undoing the equation. And so we actually undo the equation in the opposite of the normal order of operations.
Subtraction.
So the first thing we get rid of is any addition or subtraction. Remember, those are on the same level. Then we get rid of any multiplication or division. Again, those are on the same level. Then we can get rid of any exponents, and then we can get rid of any parentheses, should any be remaining at that point. And so knowing the order of operations is still super useful, just in a different way. So now we're going to go back to our original problem. So in order to solve this then, the first thing I want to get rid of is any addition or subtraction. Now in that regard, there's two possibilities. I could start by moving this 10x to the other side, or I could move this 7x to the other side. Now, currently both of those are addition. What undoes addition? Subtraction. Now, one of those is going to give us a positive number when I subtract it. What's 7 minus 10? 7 minus 10 is negative 3. 10 minus 7 would equal a positive 3. So as I'm looking at this and deciding what I want to move, technically you can move it either way, but if you want to make your life easier, keep it positive. So that means I'm going to want to do the 10 minus the 7. So that means subtracting the 7 from both sides. Now when doing this work, I expect you to actually write minus 7x underneath it and minus 7x underneath that side as well. We have to do it to both sides. And this is how the work needs to look. This is what I'm going to be looking for in your work, including your homework, in order to see that you are understanding today's lesson. Because today's lesson is not just how do we solve an equation, it's how do we show the work appropriately. Because then when we get into the really tough equations, you're going to be showing the work right, and they're going to be a lot easier. Whereas some of you have a habit of just kind of writing the least amount possible, like, you know, pencil lead is like $10,000 per gram and you need to preserve it as much as you can. No, it's cheap, it's easy to find, use it. Okay? So, I now said that I did minus 7x on both sides. Now I write the result of that. So that's going to be 3 plus 3x, because that's 10x minus 7x, equals 15. Remember earlier this year we talked about keeping the equal signs lined up? I'm still trying to keep that equal sign lined straight up here as I go down. All right, next up. I have the x's all combined into one x here. That's good. That's what I want. I want all the x's on one side. Now I need all the numbers on the other side. That means I need to move this 3 to the other side. What can I do to that 3 to make it go away?
Subtraction.
Yep, subtraction, right?
Subtract 3.
Perfect. Yep. So I want to subtract 3 from both sides. Because the goal is saying, what can I do to both sides that just makes that go away? Because I don't want that number on that side at all anymore. I just want the 3x over there. And so that leaves us with 3x on the left side. Equal sign, again, carries down and it's vertically aligned. And then 15 minus 3 happens to give me 12. Now I have 3 times x equals 12. And so what undoes multiplying? Division. And so I'm now going to write that I want to divide by 3. And we talked about it a little bit earlier this year. I do want to actually use the division symbol here. Because if we just write, as some of you do, you'll just write like over 3 like that. it can start to look like we're just subtracting 3 from both sides or adding 3 to both sides. There's some little tricks that come with that. It can cause some potential problems. It's not that it's wrong so much as just it's going to lead to problems if we keep doing it. And so write that division symbol. It makes it much easier. And I do 3x divided by 3. Notice it's divided by 3, not 3x. I want to leave the x behind.
Yeah.
And so when I do that division, that leaves me with x on the left side, and on the right side, 12 divided by 3 gives me 4 for the final answer. All right, so for this one now, let's go ahead and see how you did. The first thing here, again, I want to go backwards through the order of operations, and so I get rid of the addition or subtraction first. That means getting rid of this minus 14. What is the opposite of subtracting?
Adding.
Adding. Yep. So I'm going to add 14. So the first thing I do is I write plus 14 on that side, and if I'm going to do it to the right side, I must also do it to the left side. And that's just a habit of making sure you actually write it on both sides. Some people have developed a habit of just writing it once. Again, pencil lead is cheap. Use it. It's going to help you avoid possible problems down the line. Now we actually do the math. So 20 equals 5x. And since I now have 5 times x, I undo that multiplication by division. So I'm going to say divide by 5 and divide by 5. Again, both sides showing it clearly. Equal signs still lined up vertically. Make sure your equal signs are all going straight. And then that gives us 4 equals x for our final answer. All right, now when dealing with this one, the first thing we have to deal with is what am I actually moving? Because like if we try to get rid of the addition and subtraction first, which is, yes, what we're going to do, but if we took that to mean that we move this 10 over, that won't really do us any good. We'd end up with 9x minus 10 equals 7x, which hasn't really gained us anything, right?
No.
So as we are deciding what we're moving to which side of the equation, the thing that we want to do is we want to keep in mind that we want to move all the x's to one side and all the numbers to the other side. So in this case, in order to accomplish that, the one that I'm going to be moving to the other side to get rid of the addition and subtraction is actually going to be the 7x. That way I can move all the x's together. So notice our goal there. In the last one, I moved the numbers together. In this case, I have to move the x's together. So, how do I get this 7x out of the right side? What do I do? Add, subtract, multiply, or divide?
Subtract 7.
Subtract, yes. So I'm going to do minus 7x. Now, every now and then I'll see somebody who gets a little sloppy. They'll just write minus 7 instead of minus 7x. Again, that's going to be one of those habits that can lead to trouble. So make sure you're keeping the x with it.
Wait, why wouldn't we divide?
All right, and now at this point, I have 2x equals 10. Once we've gotten it to here, it's fairly straightforward and familiar, right?
Yeah.
Show on both sides that we divide by that 2. And so we end up with x equals, are you still keeping those equal signs vertical?
Maybe.
Still keeping them aligned? So when working this problem through, again, I like to get rid of the addition and subtraction first. Now, in that case, what would I rather do? Would I rather add 7 or subtract 5? Yep. I like adding the 7 because it means that my result is going to be positive when I do that. So I'm going to add 7.
So x.
Now, a little note about this adding the 7 here.
12.
There's 2 things I want to mention on it. 1, make sure you're doing it to both sides of the equal sign. And the other thing I'll say is you didn't actually have to start there. Some of you might have started by moving this 2x to the other side. That would also be fine. You'll find they both work, and we'll see that actually happen here. So on the left side, let's actually do that plus 7. Left side, that gives us 3x. The equal sign stays aligned. 2x. And then the 5 plus 7 gives me 12. All right. Now I can actually move that 2x over. All right, next step. Kind of like that previous one where we have the 2 different x's. I got to move the x's now to the same side. So that means moving this 2x from the right side to the left side. Now what am I actually going to do to that 2x? Add, subtract, multiply, or divide?
Add.
Well, I want it to become a 0 down here when I add them. So that means subtracting, because 2x minus 2x will become nothing,
She did it right on her.
leaving me only with the 12. And on the left side, 3x minus 2x gives me just x there. So final answer, x equals 12. Now, a little side note here, again. Some of you, when you did 3x minus 2x, you wrote 1x. That's fine. But then you have two options at this point to still get it to just say x equals. One, you could just say, hey, I know that 1x is the same as x, and you could just simplify it. The other option is you could divide both sides by 1, but it would still give you x equals 12 as your final answer.
But like you.
All right, so again, how do we start this one? I always like to start by getting rid of whatever's added or subtracted like this. So in this case, I can either add 4 or add 9 to both sides.
Why wouldn't we?
So I'm going to choose to do the 9 first because it's going to leave me with something positive. Because in order to undo minus 9, I add 9. So if I add 9 to both sides, that gives me 3x plus 5
I added 9
equals
to 3x for some reason.
8x. All right. Now, again, one of those little details that we can talk about. Notice that since this is just a 9, it has to combine with the 4. I cannot add 9 to the 3x. So x's can only add to x's, and numbers can only add to just plain old numbers.
Wait.
All right, next up. I will need to still move the x's to the same side. So I'm going to subtract the 3x from the left side, which means I also have to subtract 3x from the right side,
Where'd you get 9?
which gives me 5 equals 5x. Now, you could have started this problem doing something different. You might have started it by subtracting the 3x from both sides. If you did, you would still end up with the same thing, 5 equals 5x. Or you could have added 4 to both sides, or you could have subtracted 8x from both sides, in which case, if you had done that, this line would be negative 5 equals negative 5x. That's also fine. It just happens that it's going to leave some negatives in there that you have to deal with at this point. But I now need to get the x by itself, so I divide by whatever number is in front of it. In this case, the 5. Now, if you had done it the other way, and you'd ended up with negative 5x, you'd be dividing by negative 5 here. That's the only difference it makes. When we do it, though, no matter which way you did it, as long as you're using all of those correct rules, you end up with x equals 1. All right, so this problem, it actually brings up something that's kind of weird. So the first thing I want to do is, I'm still using all the same processes. I want to start by moving the 11 from one side to the other. So I'm going to subtract 11 from this side, which means I also have to subtract 11 from this side.
0.
That then leaves me with 13x equals 6x.
Yep.
No more numbers just sitting out there. So now what do? Well, if I had some numbers sitting out here, I'd subtract the 6x. So that's what I'm going to do. I'm going to go ahead and subtract the 6x from both sides as if it was there. So minus 6x and minus 6x.
That's exactly what I did.
Now when I do that on the left side, that gives me 7x. And when I do it on the right side, what is 6x minus 6x? 0. And so it equals 0.
Actually equals the
When you do the subtraction and it gives you 0, let it be 0. It doesn't mean there's nothing on the right side. It means 0 is on the right side. Because if there was nothing there, if we didn't write anything there, then we'd have a problem.
0.
Now, one of the reasons why you can know what's going on here and not get thrown off, because like some people talk about how they get down to this point and they just have 7x. Wait, why can't it be that? Because we can't lose the equal sign. We still have to have that equal sign in between them. If you find that your equal sign all of a sudden disappeared, that tells you something bad happened.
That means you suck.
So we still have to have that equal 0 in there. All right, we do have one last step though to make it x equals. Do the same thing you always do. We want to get x by itself. That means getting rid of the 7. So what do we do to both sides with the 7?
Divide by 7.
Yep, we divide by 7. So
You can't
divide
divide by 0.
and divide. Now when we do that, on the left side that gives me x. On the right side, 0 divided by 7 is 0.
Error.
I was right.
Because if you have no money and you decide to share everything you have with 7 friends, everybody gets an equal 0.
Well, they get the feeling.
The one that's not doable is dividing by 0. So we can do 0 divided by 7, but we couldn't have done 7 divided by 0.
Oh, that wasn't done.
And so now we have x equals 0. That's our final answer.